What if I told you that within your lifetime, humans could be living on every planet in our solar system, deep in Earth's oceans, floating in the clouds, and even thriving in Antarctica? This isn't science fiction anymore, it's engineering. Today, we're exploring the most extreme habitats humans will call home, how we'll survive in them, and what our bodies will become after generations of adaptation. From the scorching clouds of Venus to the icy moons of Jupiter, let's discover humanity's incredible future across the cosmos. Let's start with humanity's first new world, Mars. By the 2030s, we'll have permanent bases there, but true terraforming? That's where it gets wild. Current NASA data shows Mars has insufficient CO2 to create a thick atmosphere using present technology. But here's the game changer. Recent proposals suggest we could raise Mars's temperature by 30 degrees Celsius within decades using super greenhouse gases like sulfur hexafluoride, 23,000 times more potent than CO2. Picture this: massive dome cities by 2040, where you can walk outside in just a breathing mask. Underground settlements tap into geothermal energy, while orbital mirrors focus sunlight to melt the polar ice caps. Human adaptation after 200 years. Children born on Mars will be taller and leaner due to 38% gravity. Their hearts will be smaller but more efficient. Their bones will be less dense but more flexible. Martian humans might develop enhanced night vision from the dimmer sunlight and larger lung capacity to process the thin atmosphere. After 20 generations, they'll be a distinct branch of humanity. Forget the surface of Venus, we're going to live in the clouds. At 50 kilometers altitude, Venus offers the most Earth-like conditions in the solar system. One atmosphere of pressure and temperatures between 0 to 50 degrees Celsius. Here's the brilliant part. Breathable air is actually a lifting gas in Venus's dense CO2 atmosphere. Our cities will literally float on air. NASA's HAVOC concept shows how modular habitats could be assembled in the atmosphere, powered by constant sunlight above the clouds. Construction by 2050, massive Buckminster-Fuller geodesic domes filled with Earth-normal air, floating like balloons. Inside, farms, homes, even forests. The sulfuric acid rain, external protective shells handle that. Human adaptation after 300 years, Venusian humans will have the most interesting changes. Living in constant 100-hour day-night cycles as the city circles the planet, their circadian rhythms will be completely different. Higher CO2 tolerance, enhanced acid resistance, and possibly altered bone density from the constant floating environment. They might develop better balance and spatial orientation from living in a world that gently sways. Jupiter's moon. Europa hides an ocean twice the volume of all Earth's oceans beneath its ice shell. By the 2060s, we'll drill down through 20 kilometers of ice to reach liquid water that's been isolated for millions of years. The base will start as an air pocket melted into the ice ceiling, but imagine the expansion. Underwater cities with transparent aluminum walls, looking out into an alien ocean. Geothermal vents provide power, while genetically modified algae create food and oxygen. The biggest challenge? Jupiter's radiation belt delivers 5,400 millisieverts per day, fatal to unprotected humans. Solution? Live entirely underwater where the water shields us with heavily shielded surface connections. Human adaptation after 400 years, Europe and humans will be the most dramatically changed. Enhanced radiation resistance through genetic adaptation, larger eyes for the dim underwater environment, possibly gills or enhanced lung capacity for diving. Their skin might develop a blue tint from copper-based proteins that help process the low oxygen environment. Some theorists suggest Europe and humans might eventually become semi-aquatic. Saturn's moon Titan is like an alien Earth, with methane lakes, organic dune fields, and rain. The atmosphere is 1.4 times denser than Earth's, meaning you could fly with simple wings. Energy abundance. Titan has hundreds of times more liquid hydrocarbons than all Earth's oil reserves. Imagine cities powered by methane, with hydrocarbon-based plastics for construction. The challenge? Surface temperature of minus 179 degrees Celsius. But with abundant methane fuel, heating isn't the problem. It's staying warm efficiently. Human adaptation, after 300 years, Titan humans will be cold-adapted with subcutaneous fat layers, enhanced metabolism, and possibly anti-freeze proteins in their blood. The thick atmosphere means they'll have incredible lung efficiency. Most interesting, in Titan's dense atmosphere and low gravity, humans might develop wing-like arm extensions for true flight. We're closer to colonizing the deep ocean than any other planet. Right now, humans can build underwater colonies supporting 100+ people with current technology. Japan's Ocean Spiral City. By 2030, a $26 billion underwater city housing 5,000 people off Tokyo's coast. Powered by ocean thermal energy with aquaculture farms and research facilities. Key innovations: pressure-resistant transparent aluminum, atmospheric processors that extract oxygen from seawater, and kelp-based biomanufacturing. The Deep Project, a mysterious £100 million initiative starting in 2027, aims to establish permanent human presence 200 meters underwater for weeks at a time. Human adaptation after 200 years. Ocean humans will develop larger lung capacity, enhanced pressure tolerance, and possibly nictitating membranes, like dolphins, to protect their eyes underwater. Their circulation will adapt to pressure changes, and they might develop enhanced sonar-like hearing. Some might even develop webbed fingers and toes for better swimming efficiency. As global warming progresses, Antarctica might become the new frontier by the 22nd century. Parts of West Antarctica could have Alaska-like conditions by 2150. Early settlements, domed cities like the 1971 design by Frey Otto, 2-kilometer-wide air-supported domes housing 40,000 people. Nuclear-powered heating systems with geothermal energy from volcanic regions. Agriculture possibility. Areas around Antarctica's volcanoes already support plant growth. Future Antarctic cities might be built around these volcanic oases. Human adaptation after 300 years, Antarctic humans will be the ultimate cold weather specialists. Enhanced brown fat production, improved circulation to extremities, possibly larger body size to conserve heat better. Their eyes might adapt to long periods of darkness and extreme brightness from snow glare. Most remarkably, they might develop seasonal hibernation-like states during the long Antarctic winter. Forget ground-based cities, the future is in the sky. At 20 kilometers altitude above most weather, floating cities could house millions. Technology, heated air, helium or hydrogen provides lift. Buckminster Fuller's Cloud9 concept, a 1.6 kilometer diameter geodesic sphere that becomes buoyant when heated by sunlight. Advantages: constant sunlight for solar power, above storms and pollution, unlimited expansion space. Cities could migrate seasonally for optimal weather. Resource extraction, atmospheric water generation, vertical farms, and manufacturing using aerial robots that mine the ground below. Human adaptation after 250 years. Sky dwellers will develop the most unique adaptations. Enhanced balance for life on moving platforms, improved oxygen processing for high altitude, and possibly enhanced spatial orientation that rivals birds. Their inner ears might evolve specialized balance organs, and they could develop resistance to altitude sickness. Some might even evolve lighter bone structure for the lower gravity environment of floating habitats. Jupiter's largest moon, Ganymede, has a secret weapon, its own magnetic field. This natural radiation shield makes it the safest place in the Jupiter system for long-term habitation. Settlement strategy: underground cities carved into the ice with nuclear reactors providing heat. Surface operations for ice mining and solar collection during Ganymede's 7-day orbit around Jupiter. Terraforming potential: with enough greenhouse gases, Ganymede's subsurface ocean could be exposed, creating a true water world. Human adaptation after 400 years. Ganymede humans will be adapted for low gravity, 14% of Earth's, and underground living. They'll have enhanced low-light vision, stronger bones despite low gravity, from constant movement in 3D environments, and possibly echolocation abilities for navigating underground tunnels. Their skin might become pale and translucent, and they could develop enhanced mineral processing to deal with the high-metal environment. By the 22nd century, we'll have mastered living anywhere. Space habitats the size of cities, generation ships bound for other star systems, and completely artificial worlds designed from scratch. O'Neill cylinders, rotating space habitats housing millions, with Earth-like gravity from centrifugal force, complete ecosystems in space. Generational changes: humans raised in space will be the most adapted of all. Longer limbs, enhanced spatial thinking, possibly even symbiotic relationships with AI systems integrated into their biology. The ultimate question: after 500 years of living in these extreme environments, will these populations still be the same species? Or will humanity branch into multiple species, each perfectly adapted to their chosen world? This isn't just about survival, it's about becoming something greater. In 500 years, human might describe not one species but dozens. Martians with their elongated limbs, Venusians with their acid-resistant biology, ocean dwellers with their amphibious adaptations, and sky people with their aerial mastery. Each environment will forge a new type of human, but they'll all share our curiosity, our drive to explore, and our determination to make impossible places into homes. The question isn't whether we can live in these extreme places, it's which version of humanity will you choose to become. The cosmos is waiting, and for the first time in our species' history, we have the technology to claim it all. Which habitat called to you the most? Let me know in the comments, and don't forget to subscribe for more mind-bending looks at humanity's incredible future.